Hi, welcome everybody. I think we still have a few people coming in. It is the second morning, and this talk won't fill the full hour. It'll be close, but it won't fill the full hour. So we've got a little bit of time. Got a few people coming through. Excellent. So how did we enjoy the first day of the conference? Yeah? Okay. I wasn't here, so I need your opinion, all right? So I will be here for the next 2 days, but I wasn't here yesterday. So far that's only a moderate endorsement. So how did you enjoy the conference yesterday? Great. All right. Excellent. Now I know I'm in the right place. Okay. So, good morning. My name is Adele Carpenter. I'm a software engineer at Trifork Amsterdam. I spend my day building and maintaining Java and Kotlin applications for the educational sector, although more and more you will find me trying not to cause too much damage with React in the front end. So, has anyone here seen a talk from me previously? We have one? A couple? Oh! Great, excellent. So I'm a relatively newcomer, so if you haven't, that's totally fine. I really do thank you so much for supporting my work by being here today. And to the people that I have returned, welcome back. Okay, and so I do really hope that you enjoy this session as much as I enjoyed writing it. So I have spoken before about rewrites, and I use the example of Lika here, our junior engineer who just joined a team working on a large and aging Java project. And she's feeling overwhelmed with the sheer enormity and complexity of the project and feels that the only way out of her current situation is a rewrite. So luckily she is surrounded by an awesome team, and they help her see that a rewrite is rarely a good choice. And as a team, what they do is they decide that they are going to move the project forward by taking small, consistent steps in the desired direction. And I do 100% stand by that talk and that advice, but it did get me thinking, is there ever a time that a rewrite or a port is a good idea? And it turns out that this was a little bit serendipitous because around the time I started thinking about this, my team and I were presented with that very question on a customer project. So to give you a little bit of a background on Trifork, we are a project-based consultancy. The team that I work with are a little unique in that we have a product as well here called the Assessment Delivery Engine that we deliver to a small number of consumers, each of which have a custom implementation on top of our core product. So basically what it can do is it can pass assessments that comply with a certain specification and then play the assessment for the student or candidate. So it renders the questions, manages the time remaining, selects the next question, calculates the results. So we have the product part, and the custom implementations are the project part. So recently, one of our customers, the one with the most custom of the custom implementations, was starting to get a little bit frustrated with one of our applications. And to be honest, we completely shared their frustration. So I mentioned that one of the features of our product is that it selects the next question. So that seems really, really straightforward, right? You go from index 2 in a list to index 3. Well, no, not in all cases at least. So for this customer, we actually have a dedicated web service for selecting the next question. And at the core of the service is a C++ service written by a top researcher in the field of automated and computer-based student assessments. Her profile actually says automated testing, but I think for this audience, that language is a one-way ticket to a misunderstanding. So the service that she wrote is an implementation of item response theory. Now, item response theory is a family of mathematical models in psychometrics, which is the science of educational and psychological assessment. And the models of IRT are used to design, analyze, validate, and score assessments. And to make things a little bit more concrete, you can think of an item as a question of a certain difficulty, ranging from low to high. And then, as you would expect, an assessment is made up of a number of questions or a selection of these items. And the point of the assessment is to determine the student's knowledge of or their ability related to the topic of the assessment. Now, in a standard assessment, which I think you would be mostly familiar with, everyone gets the same questions. And for an average student, some of the questions will be way too easy, and for others, some will be way too hard. You could even have students where all the questions are too easy or all the questions are too hard, which actually makes the tool of an assessment pretty useless for them. So one of the cool applications of IRT is that you can estimate a student's ability or knowledge on the fly and to deliver a question that is at the right difficulty for them in that moment. And this can make the results of the assessment more meaningful. It also makes the assessment appropriately challenging and hopefully more interesting for the student. Now, I want to make really, really clear at this point that this C++ service wasn't bad. The researcher that wrote it will forget more about IRT and statistical validation methods than I will ever know. But we did have some problems running and maintaining it. So the service, while reliable and fast, was essentially a black box. So we sent it data and it sent data back. And we did not have the skills in our team to verify the results. We kind of just trusted that it worked and selected an appropriate next question for the student. Initially, there had been some simulation testing and validation done, but that was done by an external party. So adding features was just something that we didn't do out of fear that we'd ruin the validity of the underlying algorithms. And that was a key source of frustration for the customer, that the service, while useful, was essentially stagnant. Now, of course, we could contact the researcher that built the app in a pinch, but she's a busy woman and maintaining this service just was not her highest priority. Now, adding to this, the service itself was not a web service. So years ago, there was a developer in the team brave enough to write a wrapper around the algorithmic core to give us 4 endpoints that we could call. But our only options, if we got an error, was to basically just check our request and to retry. So adding to this, the logging in the core model was non-existent. So for example, if we had an item with an unexpected difficulty, which could be as simple as a typo, there was no logging to tell us what was wrong. And finally, since the core model dealt primarily with integer arrays, in order to build the request, we had to translate all of our item data into those arrays, which left our requests essentially meaningless. So if there were any issues with a particular item, it was impossible for us to figure that out. And because the service was stateless, we needed to send the entire item bank in every single request, so 60,000 lines of JSON or so. So 60,000 lines of integer arrays is not something I recommend for fun. Maybe a cure for insomnia, perhaps. So then if you did decide to be brave enough and open the code base, you were presented with code that was written in the language of the academic domain. So we had some wonderful names like these. So let's go through them very quickly. So we have APAR, not too hard, a parameter, but what does that mean? Item difficulty, obviously. BPAR, B parameter, real terms, item discrimination. So how well does the item help estimate the student's ability? CurSeg, current segment, not too bad, still not explicit enough for my liking. And theta, another one from academia. Theta is the ability of the student, the thing we're actually trying to estimate. So now that you know theta, could you please yell out your best guess for warm theta? Yeah, so you could be correct, but what I wanted to say is that it's actually called warm theta because warm was the last name of the guy that proposed this method of estimation in a paper. Not because it's actually a close guess, which it actually is, so it's just one of those cool little coincidences, I suppose. And then we round out the naming with cluster and category. So again, they're academic terms, and within the team, we use the terms friends group and domain, respectively. So I hope I've made it pretty clear at this point why the current service is problematic. So it's a black box, it's hard to reason about and debug, and trivial changes take a long time and they include a steep learning curve. And maybe not so obvious though is what makes the service a good candidate for a rewrite. Does anyone have any ideas on why it might be a good candidate? Excellent. That's one of the things we thought through as well. So I've got these in order, but I think yours is coming. All right. So firstly, we had stateless. So it receives and returns data, so we don't have to worry about a data layer or a front end. And as someone that's currently working a lot in the front end, I miss this project so much. Okay, so it also has a well-defined scope or footprint. So we need to expose 4 endpoints to one service only. So it's quite well contained. And it is a small part of the entire project. So this reduces the risks or potential downside of a rewrite or a port attempt. So this brings me to what, in my opinion, are the 3 most compelling reasons to entertain the idea of a rewrite. Personally, I do think you need all 3, but you'd want at least 2. And the reason I would want all 3 is because they each look at the question of should we rewrite from a different perspective. But first, I want to start with the reason 0 because, well, we're all developers, so we are 0 indexed by design. But also because without this reason 0, then all of the other reasons are irrelevant. So reason 0, there is a desire to functionally change the application. So if an application is running reliably in production and there is no desire to change the functionality, then I would be hard-pressed to come up with a reason on why a rewrite is a good idea. So you might see odd behavior here and there, and investigating that when it happens is the absolute bane of your existence for a day or 2. But if those are few and far between and there is no desire to change the functionality of the app, then it's probably just a reasonable cost of running it in production. As long as you can do the bare minimum to keep it running, so like bumping versions wherever necessary, using long-term support versions where possible, the status quo is probably fine. But if this is the case and you still want to rewrite, you probably need to dig down a few layers on why you actually want that. Because it's probably about you and it's not about the application or the project at all. So for example, you're just not comfortable being responsible for something that you don't understand well. So, on to the first reason why you might entertain the idea of a rewrite. And we're going to start by looking at the current service as it is in the context of the team responsible for it. There are no small steps to be found. So I stated already that I 100% stand by the advice to focus on consistency over perfection, to take small steps to evolve your application. And there's a big implication here though, which is that the small steps are in fact small. So let's take the example of the bad logging in my Teams project that I mentioned earlier. A great quick win would be add some logging, right? So in this case, given that we are a JVM-based team working on a C++ service, that would require us to run the project locally, learn how C++ works, actually learn about a lot of stuff that the JVM abstracts away, like memory pointers, identify an appropriate library, add the dependency, learn how dependency management works in C++, learn the basics of the build tool, and then pray that it runs again. So for some teams, adding logging to this application is indeed a trivial change. But for a team that lives mostly in the JVM, you need to ask, is the steep learning curve worth it? And at what point does something move from being a small step to being a large undertaking? And I also think it's a little bit simplistic to say that adding logging is always a small step. And this is the same that goes for other small steps such as improving test coverage, renaming, extracting methods, improving abstractions. Whether or not they really are small is up for your team to decide. It's not up to me or to anybody else. But what I can do is I can offer you some advice on how you might approach these discussions. And that is to be aware of your bias and to look for evidence that proves yourself wrong, rather than by having a wish and then trying to prove that it's a good idea. This will help you minimize the impact of confirmation bias in your decision making. So, for example, if you are currently feeling the pain of a legacy code base, you are likely biased towards rewriting the application in a way that is more familiar to you. So in this case, I would advise that you look for reasons on why keeping the current application in production is a good idea. So ask yourself questions like, why should I keep the existing code base? What opportunities exist to improve it? In our case, being the skeptical Dutchies that we are, we were the opposite. So we really saw a rewrite as a last resort. So our line of questioning was more around what pain are we experiencing now that can only be resolved by rewriting the application? Are the opportunities to improve the application really there? And how much work are they really? And is this really less work than a full rewrite given the makeup of the team? So this brings me on to reason 2 on why you might consider a rewrite, which looks at the team in the context of the organisation. The skills are not in the team and you do not wish to acquire them. So does the team have the skills to consistently improve the service? And if not, does the company wish to acquire these skills? So we've already established that one small step for one team could be a big step for another team. So you could be forgiven for thinking that this reason is basically the same as the first. But the key difference here is in the last part of the sentence, and that's what I want to focus on here. No wish to acquire the required skills. So this is about maintaining applications that are in line with your company or your project's tech stack. And this is a completely valid reason for considering a rewrite of your application. And it certainly was a big reason for us. So at Trifork Amsterdam, when it comes to the back end, we are very much a Java Spring shop. And yes, that includes Kotlin as well. We incorporate tools and technologies that are within that ecosystem, or at least closely related. Of course, we're all made up of individuals with different backgrounds. There is some .NET experience, and if you do go wise and grey enough, you will get some C++. But our bread and butter is Java Spring, and that isn't going to change for this foreseeable period. And we're a small company and we run many of the applications that we build. So keeping the tech stack manageable is actually a strategic advantage for us. That doesn't mean that every new service that we write is in Java, especially if startup time, memory use, or application size are priorities. But it means that while we do believe in the right tool for the job, we also know who we are and what our strengths are. And we look for good enough tooling that is complementary to our existing tech stack. So digressing a little bit here, but it also helps us avoid the pitfalls of resume-driven development. Considering a rewrite is actually a time when you can really see RDD come out in full force. Now, as the name suggests, resume-driven development is making design and tooling decisions with the primary goal of adding content to your resume. It often manifests as wanting to play around with the newest tech, even if that technology is completely incongruent with the rest of the project or company's tech stack. So if you're considering a rewrite and your eyes just light up at the possibility of doing something completely new with an unfamiliar but exciting technology, then that's a moment to just take a minute and ask yourself, do I really need a rewrite, or do I just want a playground for new toys? Or to keep the analogy going, a kitchen for new desserts. So by now, we've looked at the service in the context of the team and the team in the context of the organization. And that brings us to looking at the service in the context of the entire application. The service is small and the scope is well defined, or it can be broken up in such a way that this is true. So earlier we considered whether there are opportunities to improve the current code base as it is. Here we are looking at the suitability of rewriting the application in deployable chunks. This is all about minimizing risk and not wasting resources building something that's never going to see the light of day. In our case, our rewrite candidate was already pretty well defined. It was a stateless service that had a very small, albeit important, role in the context of the entire application. However, we still ended up with 3 deployable chunks. It absolutely was not a 3-2-1 Big Bang cutover. So if the application you would like to rewrite or port is larger and more central to your system, then it's even more crucial to plan how you will break the rewrite candidate into smaller deployable chunks. So having a small and well-defined scope for the rewrite is crucial so you can start to see the benefits from your rewrite as soon as possible. Among other things, this just reduces the risk that of your program sponsors pulling the plug on the project too soon. So back in 2004, Martin Fowler was actually the first to coin the phrase strangler application. And as an Australian, I find this really, really cool, as Fowler was inspired for this metaphor during a trip to Australia where he encountered the strangler figs. And you can see it here on the right in this photo. So strangler figs are a parasitic plant that seed in the upper branches of a tree, eventually making their way down into the soil. And in this process, they envelop the host tree, essentially strangling it, after which the fig remains in its spectacular glory. And a strangler fig application works in much the same way. So this image is based on one from Paul Hammett's blog, which is conveniently linked to from Fowler's original article. Paul is an ex-thought worker, contributor to Selenium, and strong voice in trunk-based development and branch by abstraction. And before we do discuss the image, here is the QR code to Fowler's original article, which you can take a picture of while I take a sip of water. So Paul's blog also links to a couple of resources as well, including an excellent paper by Chris Stevenson and Andy Pulse. So the rabbit hole that you can go down from Fowler's article is actually well worth it. So back to this image here. So this shows a simplified evolution of a strangler fig web application. And while it is harder in practice than in theory, essentially you rewrite a small piece of the application and run it alongside the original app. Slowly over time, you rewrite more and more of the app until eventually all traffic gets routed to the new app. So taking this approach makes it possible to weave in and deliver new functionality as you go, which can help keep the stakeholders happy and build trust in the project. And as an extension of that, it can help you keep the rewrite projects alive. Who has worked on a rewrite that got started but never made it to production? Yeah, a few hands, a few hands. So how you go about carving out a piece of your application to rewrite will depend on a lot of factors, and it might be tricky to know exactly where to start. And this is where it can actually be really handy to use a concept from extreme programming called a spike. So essentially, a spike is an experiment to explore a possible solution to a new problem. And it's so called as a spike because it is end-to-end and very thin. Now, a spike can be functional or technical, but it's usually best to start with a functional spike. So identify a pain point for your users in the current application and then build a proof of concept to tackle that pain point. Now, ideally, you would get this pain point from your users directly, and it is like bonus 1 million points if you do. But it's also just a sound approach to nominate a member of your team to act as a customer proxy. So in our case, our first users were the researchers at the customer. Together, we decided that the first deployable chunk would actually be a number of APIs, so that it would be possible to interact with early versions of the item selection models. The final application would actually combine 3 internal steps into one endpoint, but by exposing the internals like this meant that the researchers could query the model directly, run simulations, and then verify that the model did what they expect it to do. And if it didn't, they could provide feedback. And so delivering this value early, even if it was not production ready, this was really, really important in building trust and keeping the project alive with full support of the stakeholders. Further, it provided us invaluable information on how to get our first chunk to production and what the scope of that chunk would be. So, finally then, when the question came up in my team of, do we dare to rewrite, despite our strong bias against not rewriting, when we considered these 4 reasons, the answer actually became pretty clear. And I am happy to report that not long ago we decommissioned the last instances running the old application, and we are 100% running the new application in production. Thank you. We did it. So I do think that that's a pretty cool milestone, and I would like to share a little bit more about how we approached the project and what we learnt along the way. So the first step was an audit of what the current model actually did. Along with many discussions with the customer, the audit included meeting with the researcher who wrote the original application, simply to learn more about what the app does and how it does it. And on the slide here is a brief version of the results of that audit. So the audit was actually really enlightening because we discovered how many features the application actually had, and interestingly, that we weren't even using all of them in production. So for example, there was a feature called content balancing, and what that means is that if you have questions or items from different topics in the same item bank, then you can make sure that an even number of questions from each topic or category are shown to the student. Basically, the model would determine what category needs to be shown next, and of these items, which is the best match for the student's ability. However, in production, there was currently a separate item bank for each category, so we actually didn't need the content balancing feature. Now, the customer did express a desire to use that functionality in the future, so we added it as a potential requirement for a later release, but we left it out of the planning for V1. And this phase of the project was actually quite interesting as we uncovered how powerful the original model really was, and actually how little of it we were utilising in production. Because had we uncovered all of these layers and learned that we were indeed using all of them in production, then this would have been a really good moment to go back and reconsider whether a rewrite was in fact the best idea. Because you remember point 3, right? The scope is small and well defined. that's not just something you think about up front. That's something you need to keep in your mind as you go. Because I do think that this is a huge trap for developers, especially if we've just joined a project, say less than 12 months ago. It's actually a little bit Dunning-Kruger. We start to understand just enough of the domain that we think, ugh, why is this so complicated? If we could start over, simplify the data model, abstract over there, use some newer technologies while we're at it, wow, we could move faster and enjoy working this project much more in the process. But the truth about many production systems is they are the way that they are for a reason. You are not more insightful or knowledgeable than your predecessors. I know some of you might want to fight me on that, but sit with the thought. So sure, things do evolve over time, and decisions may be made in the past may be suboptimal given today's context, but often there is much more to architectural and design decisions than what is immediately apparent. So I would say that if you do decide to pursue a rewrite, treat the first phase as a discovery or feasibility phase. And this applies even if you are writing code already. Prepare yourself mentally to walk away, and if things do turn out bigger or more complex than you expected. So after the first few meetings, we had an overview of the features and the requirements for version 1. And it was decided that the new system as a whole would be a drop-in replacement for the old system. But in addition to that, the underlying statistical models would change. And this was for a couple of reasons, but the main one was to make the model extensible in the future. So, for example, the old model only used one item quality or parameter to estimate the student's ability, that being the item difficulty. However, under item response theory, there are at least 2 other parameters that can be used to get a more accurate or reflective estimation of the student's ability. And the other key reason for the change in models was, as I already mentioned, that there were other features that weren't being used at all. So the combination of unused features plus the desire for future extensibility led researchers at the customer to decide to rewrite the underlying statistical models as well. And that decision also impacted our approach to testing a little bit. In the end, it was the role of the researchers to validate their new model against the old service, and they just provided us with a list of inputs and expected outputs to add to our test suite. And overall, it was actually a really, really nice collaboration as we both analysed the existing application from different perspectives. So at Trifork, we looked through like inputs, outputs, exception handling, edge cases, whereas the researcher was actually really concerned with the mathematical mathematical methods and the psychometric validity of the model. And when we at Trifork were ready to start development of the application itself, we were provided a model from the researchers that was written in R and accompanied by mathematical notation. So this meant that the team members could work on understanding the model in a way that was the most natural for them. Personally, I preferred the mathematical notation. It's a lot more natural to me, and that helped me figure out the R code. However, for some of my colleagues, the opposite was true. And I really want to clarify here that when I say we were handed a model, really it happened in stages. It wasn't like the researchers sat in a room for 6 months and then said, here, put this in production. The researchers were actually fully aware that we planned to use Kotlin, and they did their own investigations of what libraries were available and discussed them with us. So, as for the reason as to why we chose Kotlin for this project to begin with, I hope that you already have a little idea as to why. So, as I mentioned earlier, Trifork Amsterdam is a Java Kotlin Spring shop. It's our bread and butter, it's what we do. In my team in particular, we have a strong preference for Kotlin. Believe it or not, I actually learnt to program in Kotlin. So that's how fresh of a developer I am, I guess you could say. So In my opinion, choosing Kotlin or Java within the context of a Spring Boot application is little more than a personal preference. Sure, your preference is wrong if you choose Java, but everyone's entitled to their own mistakes. Now, as for the downsides of Spring Boot, as for the choice of Spring Boot, the downsides of the framework, which are namely size, startup time, they were going to be a non-issue for us. This is a good enough choice in the context of our company and our team. So, having made the language choice of Kotlin, and together with the researchers, we actually looked at the numerical packages that we had available to us to see whether they would be a good fit for helping us to build the model. So JetBrains have been pushing Kotlin for data science a little bit, so we knew that there was plenty out there. So 2 options came up during our search, which were multi-K and Smile. Multi-K is a multi-dimensional array library, and Smile stands for Statistical Machine Intelligence and Learning Engine. So immediately Smile, just with that name, seemed overpowered for what we would be doing. However, multi-K was a solid candidate. So at Trifork, we went back and we did some small experiments. And what we found was that while multi-K would do a fine job, it didn't add anything extra for our use case. It made light work of calculations on multi-dimensional arrays, and we'd certainly be doing that. But after a bit more consultation with researchers, what we found out was that the arrays in the final model would actually just be 2-dimensional. And this is a very important distinction. 2-dimensional space is actually very straightforward. 3+ is where it starts to get tricky. Because another way to think of a 2-dimensional array is just as a list of multi-parameter objects. So let me show you an example. So here in Kotlin, we can simply define a data class of multiple primitive types. So this is a very trivial example using sales at a waffle store, just to keep the domain as simple as possible. The very first time I gave this talk, it was in Belgium, so it has to be waffles. And I was going to change the example for a local audience, but I decided that it's actually just fun to blame the Belgians for no particular reason. So if you don't like the example of waffles, blame the Belgians. So let's say you do have 2 kinds of waffles for sale at your waffle store, Stroop and Belgian. And each of them are for sale at a different price. And I know I just came for Belgian pretty hard, but that's my right as a Dutchie. To be fair, I have made the Belgian waffles more expensive in this example because they are more delicious. I know I'm a traitor to my adopted country. Please don't tell them they won't let me back in. So anyway, after you have the data for each of your products, you can define the weekend sales data of your waffle store as a list. And to upgrade this code a little bit, you could lean into the type system and define separate types for quantities sold on each day of the week, for example. And we use this pattern a lot. It means that you never confuse the sales of Saturday with the sales of Sunday during your calculation, as they are different types. The compiler will tell you right away if you try to use a Saturday value where you should use a Sunday value, and vice versa. Now, here the distinction doesn't really matter because the waffles are the same price on both days. But this extra type safety, this saved our butts more than a few times. So to give you a little bit more of a concrete example, in our model, the item discrimination and the item difficulty, they're both doubles, and they're used side by side in the code base to determine what item is the best fit for the candidate at this point in the assessment. So by declaring them, though, as separate types, we could be confident that we were doing our calculations on the intended parameter and prevent erroneous results. You don't just swap 2 doubles, they're 2 different types. So filling out now the rest of our waffle example, you can calculate the daily sales of your waffle store by using this syntactically beautiful sum of function, and you end up with 105 euros of sales on Saturday and 94 on Sunday. Now, you might have a different preference, but for our team, using the features of the collections library on a list of type-safe objects was much more natural for us than manipulating two-dimensional arrays or matrices. And it actually turned out that we could do everything with the Kotlin standard library, and the researchers' model in R was written with that in mind. They still did use matrices or two-dimensional arrays in their models, but we could easily rewrite those as lists of multi-parameter objects. And so with respect to the calculations themselves, the researchers stuck to approaches that relied on basic scientific methods. In the end, there was nothing more scary than Euler's number E and the natural logarithm, and the Kotlin math package had us covered there. So just a quick example, and as a little refresher, I did promise in the abstract a little geek, so let's geek. Euler's number E is the base rate of growth shared by all continually growing processes. That gives it a central role in many domains, from investing to probability to radioactive decay. And just like pi, E is an irrational number with a set value. Irrational meaning that there is no limit to the number of decimal places it has, and there is no recurring pattern in its numerical value. So here I've got E written out to 150 places. I hope the first 3 look familiar, unless you're asleep in high school. The other cool thing that I want to mention, though, about E is that it's its own derivative. So the gradient of a function of E is the function of E. And this isn't just like pointless trivia either. It's actually a really important property that we exploited in our model. So if we go just a level deeper now, the value of E is the limit of the following expression here. So if you keep adding these fractions, as n approaches infinity, you get closer and closer to the true value of E. And the last tidbit before we move on, given the exponential properties of E, Euler used the letter E simply to refer to exponents. But by one of those cool coincidences, like how Thomas Crapper is known for his work on toilet-related patents, the letter is just now associated with his name, E for Euler. So in terms of working with E in code, in most worthwhile languages, yes, even though I'm a Java Kotlin developer, I would consider C# a worthwhile language. You do get a convenient function exp, which is e to the power of the past value. So here you've got x to the 3, e to the power of 3 is 20.08. And you also get the natural log function, which is the inverse of the growth function. So the natural log of e to power is approximately equal to 3. Now, these two functions, combined with other basic stuff like to the power of, absolute value, square root of, they ended up being the core of our model. So while the maths involved was far from straightforward, the researchers were able to come up with a valid solution using pretty straightforward mathematical expressions. And this meant that we could write the core model in a pretty clear and maintainable way with just the standard library, which I think is pretty cool. And it also validated our choice to pick the stack based on what was a good enough choice in the context of our team, rather than trying to find the best language packages for modeling item response theory. So I'm going to do a little bit of a hard pivot now, I suppose, but if you did read the abstract all the way through, then it shouldn't come as a surprise. So I do want to shift our focus now and use the last part of this talk to shamelessly throw in some pictures of a cute dog while I reflect on taking my first steps into a leadership role as a junior dev. So one of the things that I really like about working at Trifork Amsterdam is that we don't really have fixed titles or roles enforced. We like to focus on the individual, and if there's an opportunity that comes up that matches your skill set, have at it. So even though I only had a couple of years' experience working as a developer when the project came up, I ended up taking a bit of a leadership role in this project in some areas. And spoiler alert, it had mixed results. So in my study of civil engineering and economics, I actually did quite a bit of calculus and linear algebra, and I had some experience with packages like MATLAB and Mathematica. And I am by no means a mathematical wizard, but it is a solid enough background, and at the time it was the most maths experience in the team. Adding to that, I had been working on a customer project for about 2 years, so my domain knowledge was pretty solid as well. The planets had seemed to align. And having suffered mega imposter syndrome for the last 2 years, mostly fueled by my insecurities related to not having studied computer science, I jumped at the chance to show off these different skills that I had picked up along my unconventional path to becoming a developer. And I came to those first planning meetings with much enthusiasm and lots of questions. Oh, what model do you want us to use? Where do we get this number from? How do we go about solving for this parameter? Do you have any papers I can read? To be honest, I was probably quite insufferable. But just like an excitable puppy accidentally knocking over a pot plant with a stick that is much too large for her, I got a little bit of a free pass, and most of my questions were answered. And even though I didn't understand everything all the way through, that didn't matter. I could get my head around the basics. We had a probability function, which we couldn't solve directly, but we could estimate it iteratively using the boundary closure approach. As I already mentioned, the customer was kind enough to provide a working example in R. Now, R is not a language that I know well, but given enough time and Googling, this is pre-ChatGPT, I could figure it out. I also had access to the service in C++ that we were replacing. Again, not a C++ developer, but by taking my time and annotating as I went, I could understand just enough to ask the right questions and get the right feedback and form a sound understanding of the domain. And it was pure joy for me figuring out how to turn mathematical formulas and R code into production-ready code. You know, the kind of joy you see in a dog when she starts to play with her favorite ball at the lake. And while we are a small team, so in the beginning, it was largely my task to put the proof of concept together. And that worked for a while, until it didn't. I was having so much fun that I just didn't include as many people as I should have as early as I should. Now, don't get me wrong, the project absolutely was a team effort, but the proof of concept of the core model was a pretty important chunk of the work, and I kept too much of that chunk to myself early on. I had documented some stuff, but what I hadn't documented was all the loose ends I still had in my head of exactly what needed to happen before we could go to production. And well, it was summer by now, so like a good European, I went on holiday. Now, I'm a firm believer that timing is everything in life. So you guessed it, while I was on holiday, external pressure started ramping up, pushing us to get the first deployable chunk into production as soon as possible. All those to-dos that were in my head were still in my head, and only in my head on a beach in Greece. And I came back to work, and it'd be a chaotic 2 weeks, apparently. The worst part was that some of the main issues the teams faced were non-issue to me. I felt awful. Sorry, guys. So yeah, that was a big lesson. Leadership is more than knowing what's going on and being available to answer questions. I don't like to assume that others don't know things. I know that my colleagues are smart as hell, and I don't want them to feel any other way. And I do think that this comes from my own feelings about my intelligence and my identity, that like if I'm not smart, then who am I? But that philosophy is ultimately unhelpful, and it's unfair to others. If people get offended because you want to keep track of the details, that is on them. So definitely, if I had my time over, I would be proactive in keeping the lines of communication open within the team and set an example by documenting everything as I go. Even if it's just brain dumping in a ticket, as my Uncle Fred would say, it's better out than in. And one final note on this because I think it's important to hear, even if it's just from some rando on stage. Even though I did make mistakes during my first toe dip into leadership, I am happy that I did it. I learned a big lesson, and it's been invaluable as I organically take on more leadership responsibilities as I progress in my career. So I want to make sure that you hear that message. If an opportunity comes up to extend yourself just a little bit, go for it. What are some qualities or experiences that make you a good fit, even if you don't have any direct experience in this exact task? And who can you ask for support, either inside of your team or outside of it? So speaking from my own experience, imposter syndrome never goes away, but you do get better at shutting it up. And the way you get better is by proving to yourself that not only can you do hard things, but that you can dust yourself off and try again, even if things don't go to plan. So, to wrap things up, let's revisit the title of this talk. Are rewrites always a bad idea? Yella, what do you think? Come on, don't be shy. Yes, well, I set you up here purely just based on the way I phrased this question, because it has to be no, right? Like, simply because there are no certainties in life, sweeping generalizations are always wrong, at least some of the time. So maybe the question that's better is, are rewrites generally a bad idea? And here I give a resounding yes. But they can be a good idea sometimes. So in this talk, I provided you with the top reasons to entertain the idea of a rewrite. Ideally, all of them would apply to your rewrite candidate, but personally, I would like to see reason 0 and at least 2 others. So, reason 0, so called because without this one, then all others are irrelevant. There is a desire to functionally change the application. If you're not touching the application in any way and it's running reliably and securely in production, why does it need to be rewritten? On to reason 1. There are no small steps to be found. You've determined the application does require some ongoing development, but the code base is in a state and there are no quick wins for your team to start improving it. The skills are not in the team and you do not wish to acquire them. In other words, improving the application requires a steep learning curve towards skills and knowledge that the company does not need or does not want. 3, the service is small and the scope is well defined, or it can be broken up in such a way that this is true. This means that you can deliver value and get buy-in early, and the potential downside is small. If despite the odds, you have determined that your application is indeed a good candidate for a rewrite, then you can take some small steps towards reaching that goal. So, start by conducting a thorough audit of what the current application does and what you will be rewriting. Keep it small and specific, with a healthy air of skepticism. Stay humble while you do this. The app is the way that it is for a reason, so please be curious and not judgmental. Treat the audit as a feasibility study. If there is more scope or complexity than you first envisaged, be prepared to label the project as not feasible and walk away. Yes, even if you have already started writing code. So in our case, our project was more complex than we first thought, but a lot of this complexity was in unused features. The audit helped us make sense of this and to get to a bare bones version 0.9 implementation. When it comes to the tech stack, make a good enough choice in the context of your company and team. Rewriting an application comes with enough risk as it is. Adding a new or familiar technology into the mix is just adding another layer where things can go wrong. Add value to your stakeholders as early as possible. Don't be afraid to experiment. For example, scope out a functional spike related to a pain point for your users. Put it in their hands. What do they think? Lastly, Don't be afraid to step up and do something scary. I can't promise you that it will work out the way that you wanted, but I can promise you that you will learn something about yourself. My name is Adele, and thank you so much for your time. If you'd like to ask me a question, I'm happy to chat always. Thank you.